Hello everyone, this is Tejasvi back with another video. This is the first chapter of the entire Docker container tutorial series, and in this one I am going to explain around the things around containers, a brief overview of how the infrastructure used to work before the containers came into existence, and some of the things that container does. So here is the agenda that we are having. The first one I'm going to explain on how the things used to work when there was no virtualization present. Then we are having this gift of virtual machines that is provided to us by VMware. Then we have the beginning of containers, and then some more details around the containers, and then I will give a brief around Kubernetes, what is Kubernetes and why it is present. So there was a time when there was no virtualization kind of thing existed, but at that point of time the businesses were also there. Okay, and each business might be having certain applications that they need in order to run that business, and in case these applications break, then there might be chances that the businesses break as well. So how the things used to work earlier. um, let's say there's a business X, and there is three applications: application A, application B, and application C. Now without the virtualization and all, the businesses ask the IT teams to provision some servers in order to run these three applications. Now how they do that? Okay, since there was no virtualization, each application used to run onto a separate server. So application A will go to server A, application B will go to server B, and application C will go to server C, right? And in that scenario, since there was no isolation, these applications cannot run onto the same servers. Now what will happen in that case? Now IT team must have to buy the servers which may have some good capabilities, because they don't know what the application, like when the traffic will spike, how the servers are going to handle. So what they do, they purchase new server for each application, and they make some assumptions that there might be scenarios when these applications the traffic may spike onto these applications, and they might need to use a lot of capacity. So they just figure it out, like let's say application A needs 8 GB 8 gigs of RAM in case of a traffic spike. So what they do, they buy the server for 8 with 8 gigs of RAM and a lot of hard drive, might be SSD or a hard disk, and then they deploy that application onto the server and let it run. But since they have analyzed the traffic onto the like scenario when the traffic is spiked, but right now since the traffic is not spiking, only 5 to 10% of servers are in use, and they are actually, you know, a lot of resources are going to waste. Okay, because the servers need electricity to run, and they are just wasting the resources, so they are not fully utilized. Now what happened, to encounter this problem, VMware came up with a new virtualization technology. They call it as virtual machines. Now what virtual machine is? A virtual machine is a kind of an isolated operating system. Okay, each operating system is isolated, and on a single server a multiple operating systems can be deployed. So for example, there's a host machine on which, let's say we have deployed a Linux operating system, and onto that host machine it is capable, it has let's say 32 gigs of RAM and almost 1 terabyte of SSD. Now if we deploy only one application onto the server, a lot of resources are getting waste. So how virtual machine works, this operating system, on this operating system we can deploy 3 or 4 virtual machines. Okay, let's say we have deployed 4 virtual machines, we have assigned 6 gigs of RAM to each of the virtual machine, and now in each of the virtual machine we can deploy a separate application. So all the 4 applications are now on a single server, and each application is fully isolated with its own operating system. But since this technology is revolutionary at that time, still there are a lot of problems regarding this. What are those? The first one is they need separate OS for each machine. Now since it is totally virtual and it is totally isolated, we need a separate operating system for each of the machines. Now since the operating system needs to be booted every time when the server is starting, since operating system takes some time in order to get up and running. So it generally takes a lot of time to boot up. Then if you want to migrate those virtual machines from on-premises bare metal to onto the cloud, there are a lot of overhead things involved, which might, it might be the architecture of the CPUs, it might be the image creation process of that entire virtual machine, and a lot of things. So it's really difficult, and you cannot have the same machine onto the developers desktop and then deploy it onto the bare metal servers and then take it to the cloud. It will be, difficult, and for each of the for each of those environments a separate deployment processes is generally involved. And then, since we are having an entire OS up and running into a single virtual machine, each OS, might require a separate license. So for example, if a company is using Red Hat based systems, they might be needing a separate OS and a separate license for that. Now, since, to stay up to date with the latest security patches, and in order to keep the virtual machine secure, the administrator might need to deploy patches onto the virtual machines. Since each virtual machine is totally isolated and totally having its own operating system, each virtual machine is required to do the patching. Now, what will happen in case there are one or two virtual machines? It might not be a big thing, but let's say if an organization having hundreds of applications, and they may have 200s or 300s of virtual machines. Now doing the patching in all of those virtual machines at once will be quite tedious. And then at last we are having this CPU consumption. Now, since we are assigning memory and CPU to each of the virtual machine, there might be chances like each machine will use a separate RAM in order to run the basic operating system processes, and unnecessarily they are consuming a lot of RAM because of multiple operating systems running at the same time. So to encounter all of these shortcomings of virtual machine models, the big players on the web, okay, what they did, they started using the container technologies. They developed in-house container things, and they starting deploying their workloads onto the containers. Now, what is the difference between a container and a virtual machine? Containers and virtual machines are quite similar in nature, since each of them are having a different isolated environment. Each of container and virtual machines run the applications securely, and without any worry that a machine can talk to another machine directly. So but even after having so many similarities, there is a major difference, and the major difference is the use of host OS. Now, how virtual machines work, as I have explained previously, virtual machine has its own operating system and they boot up at the time. However, the containers doesn't work that way. How containers work, they are having a host OS, and each container will be having a separate I would say separate file system. Now, since virtual machines have its own kernel and its own operating system and its own file system, the containers will be having its own file system, and for all the other things like sharing the networks, and then the kernel of the host machines, they just use the kernel of those host machines and don't deploy the kernel of its own. So that's how they are totally different. Now, since this is the file system is totally separate for each container, they are totally isolated, and one container cannot just directly talk to the other container without any kind of network interface. Now, since only a single host is present, only a single host operating system is present, it really saves a lot of computing resources. So you don't have to assign memory to each of the container, and then the container doesn't have its own separate set of operating system processes in order to run. It only uses the processes of the host OS, which is mainly Linux. So it generally saves a lot of computing resources, including CPU usage, memory usage, and others. Now, if you want to port the containers, it will be quite easy. Any developer who is developing an application and deploying its container environment on its own separate, let's say the developer's machine, the same container can be used to deploy it onto the cloud, and the same container can be used to deploy it onto the bare metal servers present on the data center. So it's really portable. And now the last one, since containers doesn't have any operating system to boot up, it's quite easy, they boot up really fast, okay, because there's no operating system in place. Now some more things on containers. First of all, containers were initially developed for Linux. There are a lot of container related technologies that are in place in Linux operating system, and using those technologies the containers came into picture. Initially when containers were started, they were really complex, and not all organizations can adhere the complexities of those containers. So what happened, Docker, this a company named Docker came into picture. They made the containers quite accessible, so that everyone, whether it can be a single developer, whether it can be an organization, anyone can use those containers and deploy their workloads onto them. Now since containers were developed for Linux only, Microsoft came up with an idea to port those containers onto the Windows platforms as well. Now the thing is, containers share a kernel, okay. Either it can be a Windows kernel or either it can be a Linux kernel. So for example, if when Microsoft wants Windows to run onto containers, Microsoft has to develop a technology so that a separate file system can make a use of Windows kernel in order to perform a deployment of a single application. So they work closely with Docker in order to port this entire container thing to Windows. And other thing is that since the port is completed, now Windows containers can only run on Windows machines, and Linux containers can only run on Linux machines. There was one additional thing, since every developer who is working on to the container environment, there might be chances that the developer is using a Mac machine or a Linux machine or a Windows machine. So in order to seamlessly work on all the three different kind of operating systems, Docker created a Docker desktop. Okay, so for Linux, for any kind of Linux based distros like Ubuntu, CentOS, anything, these distros natively support the Docker. But if a developer is working on to Microsoft platform, on Windows platform, he need to download the Docker desktop for Windows. Now what actually happens behind the scenes, the Docker desktop creates a small uh, virtual machine of Linux. It can use either a hypervisor for that, or it can use Windows subsystem for Linux as well. Now if the Docker, I mean if the developer is using that Docker desktop, it under the hood creates that virtual machine and run all those containers onto this virtual machine. So these containers will share the uh, I mean this window is this Linux virtual machine will act as a host operating system, and for all these containers, this host machine will be used as a kernel source. Similar thing goes for Mac. The Mac doesn't natively support Docker, and so this virtual machine is being deployed by the Docker desktop environment for Mac, and then all the Linux containers run onto that virtual machine. And at last, I have to talk about Kubernetes, since we are talking about Docker a little bit. Kubernetes come up as a orchestrator for all those containers. So let's say you have an application, and you can deploy one or two containers in high availability modes, so that they are available all the time. But what if your organization have a lot of applications, and there might be cases that they are going beyond 100? Okay, so managing all those 100 containers at once, and then maintaining them is quite tedious. So what Google came up with, they created Kubernetes. It is open source, and the main purpose of Kubernetes is to orchestrate all those containers. Kubernetes contains a pluggable container runtime interface, which is called as CRI. So what it is exactly, container runtime Docker. If we talk about Docker, it is a kind of a container runtime. If we talk about containerd, it is also a kind of container runtime. So all these technologies can manage the containers, the creation of containers, the destruction of containers and all. Docker internally uses container D as well. So Kubernetes has this pluggable architecture. So if you don't use Docker internally, you can always change it to a different technology which is supported by Kubernetes. Then how Kubernetes does this? It has a lot of advanced fail-safe mechanism in order to help you out to orchestrate containers. It can deploy containers into high availability zones. You can create different clusters for Kubernetes, and you can always deploy multiple containers onto the different availability zones. It really helps in case of a data center outage or anything. It has mechanisms in order to in any case the containers goes down, it can automatically bring it up. There are a lot of hard beating things so that your application can stay up and running all the time. So that is it for this video. I will be coming up with the next one. Please do subscribe, like and share for more awesome content. Thank you.